this is a brief lesson that introduces you to series and really focuses on geometric series. So just to tell you what a series is, it's helpful to start by recalling that a sequence is a list with entries separated by commas. It's just a list of numbers. A series is kind of like that, but very much not like that in that it's a sum. So instead of commas, think plus signs. There's a plus sign between entries. 1, plus a half, plus a fourth, plus, and so on. Okay. We might write it in the sigma notation. This means add up for each different value of n that appears inside. So this means start with n equals 1, go up to n equals infinity, and add up 1 over n. So that's 1 over 1, plus 1 over 2, plus 1 over 3, plus, and so on forever. A geometric series is a special kind of series for which each subsequent number is some constant multiple, the same multiple each time as the number before. And I'll often refer to that constant multiple as r. In your book, it might be called something different, but it doesn't matter. So here's a series. It's 8 plus 4 plus 2 plus 1 plus a half, and so on. And you'll notice that each number is 1/2 of the previous number. So this is a geometric series with r equals 1/2. Here we have 0.1 plus 1 plus 10 plus 100, and so on. So that's a geometric series with r equals 10. And perhaps most generally, I like to write a geometric series this way, just as a r to the n, where when n equals 0, r to the 0 is 1, so you just start with the number a is the first number that appears, and then you just keep adding to it, and each time what you add on is the previous thing multiplied by r. All right, so it's going to be helpful for us to figure out what are actually the sums that these geometric series come to. And even though here I wrote going to infinity, we're going to start with what's called a finite geometric series. So that means instead of going out to infinity, we only go out to some finite number of terms. Maybe it's 10 terms or 20 terms. And I'm going to use capital N to represent the number of terms that we add up to. So there's a cool formula for the sum of a finite geometric series. I'm going to define Sn as the sum of those terms from the 0th out to the capital Nth. So that's a plus ar squared, and so on. And then the trick is that you take this equation and you multiply each side by r. So on the left, it's r times s to the n. Then this a becomes ar. The ar becomes ar squared. The ar to the n minus 1 becomes ar to the n. The ar to the n becomes ar to the n plus 1. So I just took this first one and multiplied it by r. Then what I'm going to do is I'm going to compute this first equation minus the second equation. And if you do that, you on the left-hand side get Sn times 1 minus r. And on the right-hand side you get a times 1 minus r to the n plus 1. Then it's easy. The thing we're interested in knowing is s sub n, so we just divide through to get this expression, which we can then apply. So if we want the sum from n equals 0 to 10 of 1/2 to the n, right, so that's 1 plus a half plus a fourth, and so on, out to 1/2 to the 10th power. Excuse me, what we have here is a equals 1, because that's the first number that appears when n is 0. And we have r equals 1/2, because that's what we're getting multiplied by each time. And we're going out to the 10th, we're going out to the number n equals 10. And so what we have here is that s sub 10 is going to equal, applying this formula, 1 times 1 minus 1/2 to the 11th power over 1 minus 1/2, turns out to be really close to 2. Here's a more applied example that I really like. It's a 250 milligram dose of an antibiotic is given every 6 hours. And at the end of 6 hours, what's left in the patient's body is only 4% of the previous amount. So you might have learned about exponential decay before in a previous course. This is kind of like that, right? Whatever's in your body, 6 hours later, only 4% of it is left. But at the same time, you're getting a new 250 milligram dose every 6 hours. So the question is, how much is in the body right after the 4th dose? And I just start by trying to write things down and looking for a pattern. So after the first dose, immediately afterwards, there's that 250 milligram dose in your body. After the second dose, you have that brand new dose of 250 milligrams, but you also have 4% of what was originally given, or what was there in the previous step. Right after the third dose, you have that new dose of 250 milligrams, plus 4% of whatever there was in the previous step. So that's 4% of this whole expression. And if you expand out, this is 250 plus 0.4 times 250 plus 0.04 squared times 250. So you might guess that for the third dose, it should be the sum from n equals 0 to 3 of 250 times 0.04 to the n. So after the third dose, we added up to 0.04 squared. After the fourth dose, we're going to add up to 0.04 cubed. Okay, so we can use our formula for a finite geometric series. It's just S3 is 250 times 1 minus 0.04 to the fourth over 1 minus 0.04. Calculator says it's 260.416. That's for a finite geometric series. We can now ask about an infinite geometric series. So now we're going to go out to infinity, adding up AR to the n. Of course, this only works. This is a really important caveat. It only works when r is less than 1 in absolute value. If r is bigger than 1, then each subsequent term is multiplied by something that makes it bigger in absolute value. So it's like you're adding together bigger and bigger and bigger and bigger numbers, and it's going to turn out that that doesn't have a sum. So this only works when r is less than 1 in absolute value. And it's easy to get the answer. We just take our finite result and take the limit as n goes to infinity. So if r is something less than 1 in absolute value, when you take that to a really large, approaching infinite power, it goes away. And what we're left with is a over 1 minus r. So as an example, we could ask for our drug application that we were just doing, how much of the antibiotic is left in the body in the long run. If the patient keeps taking this 250 milligrams after 6 hours, essentially forever. And we apply this formula, it's just 250 over 1 minus 0.04. That's 260.417 milligrams, which is pretty close to what we had after the fourth dose, but not quite the same. All right, thanks for listening.